Three companies decide whether the AI boom continues. Not NVIDIA, not Google, not OpenAI. Three memory makers that most people on YouTube don't even know the names of. SK Hynix, Samsung, Micron. Together, they ship every gigabyte of high-bandwidth memory in every leading-edge AI accelerator on Earth. If any one of them stumbles, NVIDIA's next quarter slips. If two of them slip, the entire AI build-out delays by a year. So in the next 13 minutes, I'm going to walk you through the actual structure of the HBM cartel. Who is winning, who is losing, where the choke points are, and what changes when HBM4 ramps in 2026. First, why HBM matters this much. A modern AI chip, Blackwell TPU V7 MI3 5X, has somewhere between 100 and 200 gigabytes of high-bandwidth memory glued right onto the package. Bandwidth runs from 5 to 9 terabytes per second. That is roughly 30 times the bandwidth of normal DRAM, and it sits about a millimeter from the compute die instead of across a printed circuit board. Why does that matter? Because every modern large language model is memory bandwidth bound, not compute bound. When NVIDIA ships an inference engine, the matrix multiplies are small relative to the cost of pushing hundreds of gigabytes of weights through the chip on every single token. Whichever vendor gives you more HBM bandwidth, your tokens per second go up linearly. Whichever vendor cannot get enough HBM, their roadmap stalls. So HBM is not a side component. It is the rate limiter of the entire AI industry, and it is supplied by exactly three companies. Let's start with the leader. SK Hynix, the #2 memory maker in the world for 2 decades, always behind Samsung. Then somewhere around 2019, they made a quiet bet that almost nobody outside the industry noticed. They decided that the future of memory was not about cost per bit anymore. It was about bandwidth, packaging, and integration with logic. So they put their best engineers on HBM, while Samsung kept optimizing its commodity DRAM business. That bet paid off in 2023. SK Hynix shipped HBM3 first, in volume, with yields good enough for hyperscaler-grade qualification. They locked in the supply contract with NVIDIA for H100, and then for H200, and then for B200, and now for GB300. By 2025, SK Hynix had over 50% of the global HBM market, by some estimates over 60%. They are essentially the sole source supplier for NVIDIA's high-end accelerators today. The technical edge is on 12-high stacking. 12 DRAM dies stacked vertically with through-silicon vias, bonded to a logic-based die, all in a package thinner than a credit card. 12-high HBM3E is brutally hard to yield. The TSVs have to align across 12 layers within sub-micron tolerance. The thermal stress cracks dies. SK Hynix figured this out first, and a year later, no one else has fully matched them at that node. That lead translates directly into pricing power. Their HBM gross margins are reportedly above 50%. Their normal DRAM margins are nowhere close. Samsung, the world's largest memory maker, larger than SK Hynix, larger than Micron, and the company that, frankly, fumbled HBM3E. Samsung's HBM3E qualification at NVIDIA was supposed to be a formality. It was not. Reports started leaking in 2024 that Samsung's 8-high HBM3E was failing thermal qualification on Blackwell. The yields on the 12-high were even worse. NVIDIA delayed approval into late 2024, then into 2025, and even when Samsung's HBM3E was eventually qualified, it was on a smaller share of NVIDIA's volume than Samsung had originally projected. SK Hynix took the share that Samsung lost. Why did this happen? A few reasons. First, Samsung's memory business had been organized around very high-volume commodity DRAM and NAND for decades. The internal incentives, the manufacturing tooling, even the test infrastructure were optimized for cost per bit, not for the integration challenges of HBM. Second, Samsung had simultaneously been pouring capital into a foundry business trying to compete with TSMC, and that effort had spread engineering resources thin. Third, there were reports of internal organizational issues. Talent leaving to SK Hynix, unclear reporting lines between memory and foundry teams. But Samsung is not done. They have publicly committed to leading on HBM4, the next generation, due in 2026, and they have a structural advantage there. HBM4 introduces a custom logic-based die for each customer, and Samsung is the only one of the three with both leading-edge memory and an in-house foundry. If they execute, they could leapfrog SK Hynix. If they don't, the share gap widens permanently. Micron, the American outsider. For most of the 2010s, Micron was the third memory maker. Smaller than the two Korean giants, slightly behind on every node, perpetually in third place. On HBM specifically, Micron was so far behind that for a long time, the industry treated it as a two-horse race. Then something changed in 2023. Micron skipped a half generation and went directly from a small HBM3 effort to a serious push on HBM3E with 8 high stacks. By 2024, Micron's HBM3E was qualified at NVIDIA. By 2025, Micron had grabbed a meaningful slice of the HBM3E supply for Blackwell. Estimates put their share between 10 and 15%, with reports suggesting they could push toward 20% through 2026. There are two reasons Micron is suddenly competitive. The first is technical. Micron used a slightly different approach to the TSV process, partly out of necessity, since they didn't have the same maturity as SK Hynix, and that approach turned out to give them a small thermal advantage on 12 high stacks. The second reason is geopolitical. Micron is the only American HBM supplier. The CHIPS Act, Department of Defense pressure, and NVIDIA's desire for supply diversification all push the same direction. More Micron, less concentration in Korea. Micron is now expanding HBM capacity in Idaho and in Taiwan, with significant U.S. government backing. Will Micron catch up? On HBM3E, no. That race is already decided. On HBM4, possibly. They have closed the technical gap faster than anyone expected, and the structural pull from U.S. policy is real. So why is HBM such a hard market to break into? Why has no forced supplier emerged in 5 years of relentless demand and obscene margins? The answer is that HBM has 4 structural choke points, and you have to be world-class at all 4. Choke point 1, advanced node DRAM. HBM dies are built on the most advanced DRAM nodes, currently 1B and 1C class, moving to 1D in 2026. Each node shrink takes years and tens of billions of capex. Only the existing 3 players have the cash flow and the cumulative process know-how to keep up. Choke point 2, TSV manufacturing. Through silicon vias are tiny vertical wires that carry signals through every die in the stack. You drill them, line them, fill them with copper, polish them, and bond them together with sub-micron alignment. Defects compound exponentially with stack height. 12 high HBM has thousands of TSVs per die. One bad via, one micro warp during bonding, and the entire stack goes to scrap. Choke point 3, logic die integration. Modern HBM packages sit on a logic-based die that handles the interface to the host. With HBM4, that logic die becomes customer-specific, designed to match NVIDIA's interface, or Google's, or AMD's. To play here, you need either an in-house advanced foundry, like Samsung, or a deep partnership with TSMC, like SK Hynix has built. Choke point 4, qualification cycles. NVIDIA, Google, and AMD don't qualify HBM in months. They qualify it in years, with thousands of hours of stress testing, thermal cycling, and field reliability data. A new entrant has to start that clock years before they can ship a single die. By the time they finish qualifying, the leaders have moved to the next node. 4 choke points, all expensive, all multi-year, all reinforcing. That is why the cartel exists. Not because of collusion, because of physics, capital, and time. So who actually wins? And what does the customer leverage look like? Through 2026, SK Hynix wins. They have the technical lead on HBM3 12 high. They have the NVIDIA contract, and they are first to sample HBM4. NVIDIA gives them allocation priority because, frankly, NVIDIA cannot afford for HBM to be a constraint on Blackwell or Rubin shipments. SK Hynix gets to charge premium prices, and they reinvest that into the next node. In late 2026 and 2027, the picture gets more interesting. HBM4 introduces the customer-specific base die, which structurally favors Samsung's combined memory plus foundry play. If Samsung can execute, Samsung has the most to gain and the most to lose. If they nail HBM4 yields, they can take share back. If they stumble again, SK Hynix locks in dominance for another 2 years. Micron is the wild card. They probably won't catch SK Hynix on raw share, but they will pick up wherever NVIDIA, AMD, or hyperscalers want to diversify supply away from Korea. The CHIPS Act money keeps flowing, and Micron's HBM4 roadmap is more aggressive than most analysts gave them credit for 2 years ago. But here is the part that nobody on YouTube wants to admit. The customer, NVIDIA, Google, AMD, has less leverage than they would like. There are only 3 suppliers. Switching costs are years of qualification. Demand exceeds supply by a wide margin. So the HBM cartel sets the terms, and the AI labs pay them. NVIDIA's record gross margins are partly because their customers will pay anything for compute. They are also partly because NVIDIA is paying SK Hynix anything for memory in pricing it through. The cartel sits underneath the entire stack, quietly extracting margin. That is the honest answer. The AI boom doesn't run on GPUs. It runs on 3 companies you've never seen on a magazine cover. If this was useful, subscribe. This channel is where the actual semiconductor industry view of the AI race lives, not the marketing slides. Next video, we go deeper into TSMC and the foundry side. Drop a comment with what you want broken down. Thanks for watching, and I'll see you in the next one.